Yes, sir.
Okay, I'll start.
Yes, please go ahead.
Hi, everyone. Welcome to another talk of Ascend. So this month's talk, I'm going to be talking about this subject that everyone knows, uh, but I'll hopefully add in a bit more of what it means in this talk today. So it's about experiments. And what do? You go from books and you start doing things, you go to practice. So let's see how exactly uh, experimenting works. I'm sorry. Okay. How exactly experimenting works in the field of science, and I'll bring it up in Vedanta as well. So traditional science, as we know, we say it's a subject that we study in schools since class 1. So all the kids go to school carrying their science textbooks. And then later on, it can branch out into individual subjects like, let's say, chemistry, physics, mathematics, and so on. So what typically happens in schools as we study science is, you have this bunch of textbooks from which we read. There's a teacher who explains science to students, and then there's a student who learns it from the teacher and also from these books. This is how science education is being imparted in most schools today. And this is how standard science is also done. So if you look at the evolution of how science knowledge gets trickled down into the society, you have some great scientists, let's say like Newton or Einstein, and these people go and discover some things. And once they discover, they publish papers, they write books about their findings, and then that knowledge gets passed on to a teacher. So the teacher learns these concepts and he teaches it to the student. And the student picks it up, he learns it from the teacher, he learns it from books. And this is how in most schools, in almost all schools today, science knowledge gets trickled down into the student. But what I'm going to talk about today is the forgotten aspect of science, the fun aspect of science, so as to say, which is experimenting. So the student, once he picks up this concept, has to go and experiment this concept to test if it works or not. Most often than not, the student just learns the concept from the book and he believes, yes, Newton said it, so that must be right. Einstein said it, so that must be right. But the fun part of science and the most important part of science is for the student to go ahead, experiment and test the theories himself. So how did it work? So when Newton figured out, so it wasn't easy for him either, right? So we have all heard this fancy story of an apple falling on Newton's head while he was sitting under an apple tree, and then he thought why an apple fell, and then that is how he went on to discover laws of gravity. Similarly, Newton figured out a bunch of things. So Newton figured out he has his own laws of motion as well, how object moves, and it's called Newton's laws of motion. So Newton figured it out. So what can we do? So we can go ahead, learn these laws that Newton has suggested, and then go ahead and test it. So the least that students can do is try to understand and interpret Newton's laws in our own way by doing some experiments. So for example, over here, this boy gets an idea. Okay, so then Newton's law states every action has an equal and opposite reaction. So he goes ahead, fills air in the balloon, releases the balloon. So the action is air getting the balloon moving upwards, and the reaction is the air pushing downwards, so which follows Newton's law. So we need to develop our own methods of trying to interpret these Newton's laws. So this is the forgotten aspect of science. This is the fun part of science. This is the experimental part of science. So if I were to like broadly show how the cycle of science is. So first, there's a scientist. The scientist discovers these laws of the universe, and then he does an experiment to verify these laws. So he has, let's say he does some experiments. So he has a thought experiment, or he goes ahead and does some things and he experiments. And then once he experiments, he arrives at certain truths. For example, Newton, after doing some thought experiments, realized Newton's laws of motion. Einstein did some thought experiments and arrived at relativity, and so on and so forth. So they do some experiments and they arrive at their truth with some law of universe or something of that. So once the scientist has obtained some truths, they go ahead and publish it. So they compile the truth and then goes ahead and publishes it in books, in papers, and so on and so forth. Now this compilation of the truth becomes a borrowed truth, because it is what the scientist has said, and so the scientist has experienced some things, and then the scientist has written it down in forms of books, and this books goes on and reaches many other people, and that becomes their borrowed truth. So, and then that borrowed truth reaches a student. So this is how standard science education works in school, where there is some scientist over there who has already discovered things and compiled it, and the student just picks up these borrowed truths. Now, what is essential to do for the student is the next two steps, which is, so the student has to go and experiment it. So the student has to understand why Newton's laws work the way it is supposed to be. So he should come up with his own set of small experiments to verify these truths. And then once the student has experimented, the student will arrive at the student's truth. This is what the student has understood. The only thing that the student understands is the truth, is the student's truth. If the education is cut off here, the only understanding he has is a borrowed truth, which is not a real understanding. What he needs to understand is his own truth, which is the student's truth. So this is the missing part. And today I'm going to talk more about this missing part and how to inculcate this missing part into our lives, and how this missing part is also essential in understanding concepts in Vedanta. So I'll take a simple example. Most of us would have done some form of cooking in our lives. So I'm going to take a cooking example. So over here you have a list of ingredients with their measures. I haven't put the way to cook it, but you have that also on the internet. So there's this half cup tur dal, oil and salt and so on. And all of this is somebody's recipe to make sambar. So now if I just show this to some person, some cook over here, who has never known what sambar is in his life. Let's say he's a person from US and he's never known Indian cooking. And you ask him what is sambar. He doesn't know what sambar is. Now you show him this recipe, the way this exact recipe, you show it to him. So you say, okay, you measure this much tur dal, and you say, okay, you have to put this much oil and so on and so forth, and you give him the right cooking instructions. So everything the cook knows. He knows what ingredients to take. He knows how to cook it. He knows how long to cook it. He knows the flame temperature. He knows everything. But if I ask this cook who has only read about all this and never cooked sambar, never seen sambar, never tasted sambar in his life, for him sambar will always be this ingredient list. But if you ask a cook what sambar is, the cook goes ahead, takes these experiments, makes his own version of sambar, makes his own sambar. And then if I ask this same guy what sambar is, he'll say, okay, so he'll have a picture of sambar. So sambar is something spicy, sambar is red in color, sambar is tangy, so on and so forth. And he'll have so much description to put to it. So this is kind of the essence that I want to drive with the current, with where the science education traditionally ends and with where experimentation begins. So with just a traditional science education, all we can come to know is the set of ingredients. We'll never have a feel of how sambar tastes. We'll never have a feel of how spicy sambar is. We'll never have a feel for the color. We'll never have a feel for the vegetables in it, so on and so forth. We all the science education is like how the recipe is stored in our brains. So if it's only the recipe that is stored in our brains, we will still know what sambar is. We'll still know how to cook sambar because it's all there in the instructions. But you would never have the experience of realizing the taste, realizing the color, realizing the texture of that dish. So this is precisely what experimentation does. It connects these books to some sort of a real life experience that you have. And now this sambar that you have made is your own truth. How spicy a sambar is, how red a sambar is, how tangy a sambar is, only you can say. That is your own truth. So it's your own sambar now, not someone else's borrowed recipe sambar. This is the importance of experimentation in life. And it can be something very simple as cooking things. And it could be as complicated as trying to understand extreme models of the universe. So all it needs is this yearning to know. So you want to keep understanding things. So you want to know why things work. You want to know what sambar tastes like. You want to know how sambar feels like, and so on and so forth. So all experimentation needs is an intense yearning to know. So in this cycle that I mentioned before, the step that takes a student to the student's truth is this yearning to know. And this is what propels him to do an experiment and realize his truth. So these experiments, they can be, it need not be something very physical. It need not be like you going and cooking something or you playing around with chemicals. It could, like I mentioned before, it could it could simply be some thought experiments as well. For Einstein was a famous theorist. So theorists have thought experiments. So they think, okay, what happened if light actually behaved this way instead of some traditional way? So they come up with these kind of thought experiments, and an experiment need not even be physical, like I said. So all it needs is a wish, a yearning to know how things work. So this is the important part. And what experiments lead you finally is conclusions that is now your own truth. So what you have is a model of the universe that you know now. What you have is a version of sambar that you have tasted, that you have understood it. So what experiments really do is it takes you from someone's truth, a borrowed truth, to your truth. So now how does all of this model of science fit into understanding Vedanta? So I will go again. I'll again go revisit the cycle that we have. So in science, you have a scientist. So here I'm taking Albert Einstein. So he is a great scientist, and he did some thought experiments. So he wanted to know how light uh, how light works. He wanted to know what happens when things move with respect to each other at very high speeds, so on. So he thought about these things. So he did a lot of thought experiments, and then he arrived at some truths. For example, what light is made up of, or what or how exactly does relativity work. And he arrived at these truths, and he published in papers, and he wrote books about it. And then he compiled all of his results, like I said, and he's published a lot of books. So here you see a book by Albert Einstein. The topic is, I mean, the title of the book is "The World as I See It." So he has compiled his own interpretations of how the universe is supposed to be, and once he's compiled it, that becomes the borrowed truth for others, because it is actually Einstein's truth. So, and then he passes it on to the student. So now the student goes ahead, does some experiments. So here we have a version of an experiment that was used to detect one of the predicted things, one of the things that Einstein had predicted. So we went ahead, made these huge experiments, and then we realized and we realized our version of Einstein's truth, which has now become our truth. So how does it work in Vedanta? So here, instead of a scientist, you have an enlightened master. So here, for example, I've taken Ramana Maharshi here. He has done some experiments. So he has experimented his own ways of his own takes of what Vedanta is, and he has arrived at some truths. So that is the master's truth. So, and then there's a compilation of his truths, which has been so there's a compilation of his truths. And one of the books that I mentioned over here is Ramana Maharshi's Upadesha Sara, which is a small 30 stanza poetry work, which has all these deep truths that Ramana Maharshi discovered. And then there's a student who picks it up, who picks up Ramana Maharshi's work. And now what the student has to do? So the student has to experiment on his own. He has to realize the truths that were discussed in these compilations. And then the student arrives at the student's own truth. So if you see the cycle of how Vedanta is, and if you see the cycle of how science is, it's really the same. So we have a master who has discovered. We have lots of masters who have discovered truth, which has been compiled, and now we as students have pick it up and discover the truth by ourselves. So this is the essence of both science and Vedanta. So there's something special about Vedanta, though. I want to term Vedanta as the mother of all experimentation. It's the biggest experimentation that you can undergo. And why is that? Because typically in all other experiments other than Vedanta, you have an experimenter and you have something on which you experiment. So it could be anything. It could be a concept. It could be any concept really. It could be like a thought experiment, or over here you see the student is doing some chemistry. So be some chemistry experiments. And And in all of these experiments, there's always an experimenter who's doing the experiments, and there's some experimented object. For example, over here you have some chemicals, and it's going to give some new results. So, so now if you ask, whose truth is it? So the student arrives at some truths. The object over there has its own truth. It has its own nature. The chemical, when you boil water at 100 degrees Celsius, it starts evaporating. So it's one aspect of water. It's one truth. So the object over there has its own truths, and what you gather is your own truth. Now, if you ask, is the truth of the object and is the truth of the experimenter the same? There's no way to answer this question, because the object's truth and the because the experimenter's truth is the experimenter's truth and the experimenter's truth. There is always an underlying subjective background which can never be understood objectively. And so the experimenter's truth and the experimented truth, the subjectivity part of it, can never be compared. So you can never know whose truth is it. The subjective part of the experimenter and the subjective part of the experimented truths can never be verified if it is the same. But in Vedanta, the experimenter and the experimented is the same person, which is you. So the experimenter and the experimented becomes the same, and so there is no need of verification of the truth, because truth is the same. And so Vedanta is, I call it the mother of all experimentation, because you can't be more true to yourself than yourself. So how does yearning of science lead you to yearning in Vedanta? So I call science itself as the sadhana towards Vedanta. And just like how you have various meditation techniques, bhakti, and so on and so forth, doing science also helps in Vedanta. And what it actually does is it helps you develop an intense yearning to ask deep and necessary questions that you have in Vedanta. And it also helps you develop a strong sense of passion to keep at these questions all the time. So finally, a summary of what I've said is we need to start from where traditional education ends. We need to go ahead and experiment on our own. We need to move away from books and experiment and explore. So finally, I just want to end up with, so it's Diwali. So I just want to, so it's a festival of lights. So we need to ignite the fire of passion to know and develop a strong sense of yearning and understanding in life. Thank you.
Excellent.
Any questions?
Yeah, wonderful. So beautiful. So Vedanta is a mother of all experience. That's very nice.
Yeah.
Yes.
So, Pranav, one question.
Yeah.
How do you say in physics or
Yes.
sorry, in science, this
Yes.
the truth of the experimenter and the experimented is need not be seen? Can you say that with an example?
Science will never say that, because science is always trying to match the experimented truth with the experimentalist truth with the experimented truth. That is the basis of science. So science always says something is reproducible. If it is not reproducible, then that is not science. So for science to for science to exist, there has to be always some commonness in these truths.
So I would say that science, I don't know if really, science says this is what is observed as truth, but science doesn't claim it is the truth. Am I true?
Yes. So it says, so what we say is, okay, so we try to go as detail oriented as possible. So we say in so and so conditions under so and so things happen. And we say in this region, this is the truth. Don't know what happens in other regions.
So basically, science doesn't speak about truth. Science speaks about a fact under certain conditions.
Yes. So science speaks about certain, for example, water boiling at 100 degrees Celsius. So it is a very common thing for all of us to see when we cook. For example, if you place a thermometer inside, you say, oh yes, water is boiling at 100 degrees Celsius. And so now if I, so now, so I narrowed this whole process of things where there are infinite things happening. I started putting tags to it. I said, okay, there's something called as temperature, and I defined a scale for it. And then I defined what water is, and then I defined what boiling is. All of these are approximations. What temperature is an approximation, what water is an approximation, what boiling is an approximation. So under all of these approximations, something happens. This is what science is.
So, for example, the truth of experimented and experimenter, can we explain here that it is the experimenter's truth at atmospheric condition, and let's say if the atmospheric pressure is higher, the temperature may be different at which the water boils.
So we have a theory for that as well. So it's more like it's a bit more deeper than that, because if you say so let's say in the same water boiling example, we have a theory of what temperature is. So now so let's say Newton's laws of motion. So there's a theory for it, which says if you push a body, it will move forward and it will have some acceleration. Now this theory is seen for almost all objects. I throw this, it goes. I throw another object, it goes. I throw on my wallet, it goes. And all of these objects seem to be following this laws of motion. But there is a regime where Newton's laws break down. Quantum particles don't behave the same way as Newton's laws. Very high energy particles don't behave the same as Newton's laws, and that's where all of Albert Einstein's theory and all of these other theory comes up. So it's more like science is always looking for new things to improve an existing knowledge. So that
what
we
I was saying is truth is conditional there.
Yes.
Or the truths that experiments have to look at is what is the conditions.
Yes. So it is under some conditions that you work out so and so objects behave in so and so ways. Yes.
So is it not true even for Vedanta, Prabhuji, that the experimented and experimenter truths, in this case both are maybe same, but still truth is based on condition, or the so-called facts are based on conditions? We want to make a distinction between truth and fact. As you said, in science, what Pranav is saying here, truth is actually a fact, but these facts are based on some conditions. Similarly, even Vedanta's what is observed is based on some conditions or not?
Fact is available for objective experience, objective experimentation. And we can, the truth is a subjective reality. So truth is different from fact. The words are not interchangeable. In Vedanta, anything you observe, either through mind or sense organs, is still considered as a fact only. And fact is, as far as fact is concerned, it is subject to the error in our interpretation and understanding, whatever subjective error is there. So Vedanta goes to the root of the observer and tries to get rid of all errors in observation in terms of mind, body, intellect, by going through a process of neti, not this, not this, not this. So all what I'm saying is subjectivity is removed. Then what remains is a pure subjectivity. And in that pure subjectivity, there's no subject-object relationship. That Vedanta calls as truth. And that is the only truth possible where subject-object duality disappears. Because there's no error in observation. There's no objectivity in that. So this is actually, I would call as Vedantic realization is a pure subjectivity, free from all objectivity. When you realize the self.
Yeah, while
So
science
in that
is all
sense,
about pure objectivity.
Science is about objectivity. And Vedanta is about pure subjectivity, where there's no error in observation. Possible. Error is not possible because we are not using an instrument. All instruments are discarded finally.
Okay.
When you come to neti, finally there's no instrument left. Even the intellect which is used for discrimination, that's also dropped. So that we call as nirvana, there is called self-realization, all those names.
Okay.
So this is on the inner side. Then Vedanta also says, not just go inner truth, the truth, observe the fact also, observe the world. And about the world, Vedanta teaching is, the world is mithya, unreal. So unreal means it is a perception, it's not a reality. No matter how, whatever you try to do, there's a perception error comes into picture, and perception is never a reality. So that way Vedanta comes to the understanding of the world as the fact as a perception, and perception is never real, and what is not perceived is the reality. So Vedanta addresses both fact and truth, whereas science addresses only truth, only fact.
Okay.
So am I making sense?
Yes.
For
Pranav.
Yeah. So any kind of an objectivity is going to be a concept. It's going to be an understanding in the intellect.
Right.
So any sort of an understanding is by definition limited, because there is no way to understand an infinite thing.
Right. So I would yeah, go ahead.
Yeah, no, that's it. So yeah, go ahead, Guru.
So I would say a fact is objectively understanding an object. A truth is a pure subjectivity. So Vedanta addresses both fact and truth, whereas science addresses only fact. And when science reaches when the science goes into the fact and reaches the truth of the fact, then science is no longer there, only Vedanta is there.
Sorry, the last sentence.
I'm saying science probes, science tries to get into fact of the matter. So finally, science, all scientific errors, perception errors are removed, then only Vedanta remains. Science disappears into Vedanta.
That's what you're saying is now happening in modern science. Yeah. No, but very important thing is about in the process in science, Pranav, how does a student experiment if he has not understood the method of experimentation of the scientist? So in some places it is available, some places it's not available. So how does he experiment?
So for experimenting, you don't need anything. Like I said, you can do thought experiments, right?
No, I'm
So
not looking at the constructs of the I'm looking at the process of experimentation. Let's say even in a thought experiment,
yeah.
how does a student, what should he look at, how to conduct a thought experiment?
So it's as simple as how it's as simple as how you want to have some things in life. So everybody is running behind money. So you ask how to get money, and then he'll come up with some set of things to do in order to come up with money. Right? So it's as simple as that. So you say, how did Einstein come up with this theory? And then you come up with ways of you come up with ways. So then you'll do a lot of things. So the details, the specifics of the details is dependent on how that person reacts to something. So let's say you want to study relativity today. So then you go, so what I would do is go read what people have compiled and understand why things are happening its own way. Now, if I don't, let's say from step A to step B, I didn't understand the route, like what the mathematics, for example, some aspect of things that I didn't understand, I'll go ahead and try to understand that as well. Why is it behaving that way? So the way of understanding is going to be different for everyone. The way I understand addition, 1 + 1 is equal to 2, is not the same way you understand addition, 1 + 1 is equal to 2. For example, in my mind, when I say 1 + 1, I think of I think of one chalkboard and another chalkboard, add up and I get 2 chalkboards. But the way you think 1 + 1 is you have a symbol 1, and then which represents 1, and then you have another symbol 1 which represents 1, and then you combine them and you get a symbol 2 which represents 2. So the way of understanding is going to be different for each and every one. And this is really the part of experiments, and this is really, and the final way of understanding is what I show over here as the student truth. So if 1 + 1 is equal to 2 is just taken in textbook, and then you just don't think about it, then it will always be some form of a 1 + 1 is equal to 2. It won't be your form of understanding.
Symbolic understanding.
Yes.
2 is a symbol. That's the understanding.
Yes.
Whereas, yeah. So if you go deeper, the same 1 + 1 = 2 becomes more a physical understanding.
It becomes, so the understanding just takes root in different people in different ways, and there are like infinite ways of understanding the same concept.
Good. Okay.
One challenge is there. Let us say I go to pure subjectivity and I realize some truth. And Shravan goes to pure subjectivity and realizes one truth. Is my truth and your truth are one and the same?
So the question,
is there only one truth or 2 truths?
So the question is, what is my truth then? Because as soon as you say my truth and your truth, then there's objectivity. and those two will never be the same. But if you say just truth, then there's nothing to compare as well.
So basically, Vedantic truth is not verifiable. Scientific truths are verifiable.
Yes, objectivity is very objectivity. So but there's also this one caveat of what verifiable is. So again, it's going to be under so and so conditions, under so and so things. With all of these caveats will come. Right. Things seem to be, and then you again say things seem to behave the way that those people thought.
Conditions apply,
But in reality, even that cannot be verified. Yes, it's always terms and conditions apply.
See, Vedantic truth, ultimately somebody says I am enlightened, somebody is liberated. There's no way, or rather somebody claims or somebody believes is enlightened. There's no way anybody can verify except by symptoms of some symptoms they will call as Sthita Pratna Lakshana, which is externally visible. But really inner truth, who has understood what, nobody can understand from outside.
Looks complicated then.
we can only speak of symptoms of enlightenment or symptom of liberation or symptoms of realizing truth, not truth itself.
Yes. So
And symptoms, of course, are subject to again perception errors.
Okay. So while Vedanta claims one truth, that one truth is not universally, there's no standard for understanding what is that one truth universally.
No. One truth is claims that one truth is what you have to find out yourself of when you are not there.
Okay. No, but
until then it will just be a concept.
Prabhuji, there is as a comparison between this term borrowed truth and the real truth in what Pranav is saying.
Right.
There is a comparison in Vedanta also, Vacha Vedanta and Anushtana Vedanta. Vacha Vedanta is only talk, where it is understood but not experienced in whatever way. But Anushtana Vedanta is something that you experiment. Now, I know this is a lot of, there are a lot of pitfalls here in understanding these things. Do you think there is something like Anushtana Vedanta and Vacha Vedanta, or one will lead to other easily? You're muted.
Oh, I think he's not muted, but there's some noise or something. We are not able to hear. The mic is far.
I log out and log in.
Yes. Now we can hear.
Yeah, you can hear me?
Yes.
Okay, so we are using 4 terminologies in Vedanta: Paroksha Jnana and Aparoksha Jnana. Paroksha Jnana is an indirect knowledge. It is not my truth. It's a second-hand truth. It's a borrowed truth. Aparoksha Jnana is my direct experience of truth, whatever truth we call as. So this is equivalent of Pranav's saying Einstein's truth becoming my truth in that sense. So now Vacha Vedanta is equivalent of somebody's realization. Anushtana Vedanta is experimentation which I am doing. It's not, I have not realized the truth. I am experimentation I am doing. So that Anushtana Vedanta is the experimentation process. So in Vedanta, the experimentation is a very standard way of experimentation is there. It's called Prakriya. So the way Prakriya or process of experimentation or exploration is well defined in Vedanta, Prakriya. Now, how somebody understands the Prakriya and applies it, I don't know. That's a subjectivity. But the Prakriya or a process of experimentation is well defined, just like science is defined. This is a process of experimentation. The Prakriyas of Vedanta are well defined. But how somebody understands it, how somebody applies it, we can't say anything about it, just like Pranav said. So, Anushtana Vedanta, Prakriyas you have to apply. So, Paroksha Jnana is somebody's truth. Aparoksha Jnana is my truth. No, Shravan, unmute. You have to unmute. No, we are not able to hear you.
That's clear, Prabhuji. Thanks. So we have any question from Vinay or Srinivas Murthy?
Shriram is there. Shriram, or do you want to ask any questions?
Hi, Shriram.
Hello, hello, Pranav Guruji and Shravanji. This was actually a very unique and enlightening session, I should say. It gave me a very different perspective of science itself. I don't know, it was a half an hour talk, but it was very so insightful. I don't know, I can't say anything more.
What is insight? Can you share that insight?
No,
Inside,
mainly,
outside.
mainly what Pranav told about the objective, I mean the experiment in science. There is a objective experiment, and I mean what I realize may not be the same as what is there, what is the truth in the experiment of science. Because in the objective experiment, we are trying to understand something infinite, which is not possible. Like the example he gave of boiling water. So we define something called temperature, which is an approximation. We define water itself, which is an approximation, and we have some understanding which varies from person to person. So when objectivity comes, there itself there's an approximation and an inaccuracy, which is an illusion. So the only place where this inaccuracy tends to zero is when there is no duality. So that is that's why Vedanta is called the mother of experience. This was very I mean, it struck very well. It was very nice.
Vedanta is subjective reality, Guruji.
Vedanta is
pure subjective reality, Vedanta.
Pure subjective.
And whatever may be, it is only on the based on the material external objects. So
Correct.
we cannot compare the Vedanta with that science, because
No. Science will lead to Vedanta.
The,
Science is actually matter is exploring. It will come to a point where matter is not there.
yeah.
Then what is left is Vedanta. Pranav, I am under the have an understanding that quantum theory, quantum mechanics almost converges with Vedanta. Am I real? Is my understanding true? Quantum physics, I'm saying.
So if you look at the history of quantum mechanics in general, all the people who came up with these theories in the 1920s, 1930s, if you look at them really, they're all philosophical as well. And
Correct.
they're very much attracted by the principles of Vedanta.
Right.
So in that sense, you can say it becomes close. But how do you get close to an infinity? There is, like, you say 1,000 is close to infinity. No, you say 1,000,000 is close to infinity. You say 1,000,000,000 is close to infinity. No matter how much close you go, it'll always be far. That's the fun part of infinities. But nevertheless, what people actually found out, so the closest working theory of the universe that we have is something called as the quantum field theory. Without getting into the details of it, what people understood in the field theory is that there can exist things even when they don't seem to be. So there's a concept of something called as a vacuum field, where there is no particle, yet it's there, and it has some finiteness in terms of energy and things like that. So this is a very profound realization in science, so as to say, when people came up with this theory. And it really speaks that there is something even when nothing is there. So in that way, you can say that people who do fundamental quantum mechanics research, let's say, are very close to Vedantis.
Theory, Pranav.
Yeah.
Quantum field is what we call as quantum vacuum. Is that same thing you're speaking of?
No, so the quantum vacuum is still a thing. So it's the quantum vacuum that I'm talking about, where apparently nothing seems to be there, but there's still something. We call it a vacuum field. But what exists is still this. So the idea of the universe that we have right now is that there's all these. So the field description is the most basic thing. How a field is spread out in space and time is the most basic or the most fundamental form of understanding of the universe. And it's not necessarily the particles like electrons or things like that. So even when no electrons exist, when no matter exists, the field still is there. And this is a way of understanding that there's no matter, but yet there is something. And that is what we call as a quantum vacuum. That is the vacuum.
See, there are two aspects of life. One is a matter and information. Information I won't call as matter. So is the quantum vacuum a field of information?
I don't know how we are defining information. Because in science, at least, so the way science has always worked is you have very set of precise tags for things. So we have a very precise way of defining what information is.
See, for example, for me, let us say the world to appear, right? The world to appear, there's a structure and pattern in the observed universe. Okay. And the structure and pattern is in some form present that I call as knowledge. Now, the world to appear this way, there must be some knowledge in a unmanifest condition or originally, which will appear like this. So that I would call as information. I don't know whether I'm precise, but so what appears is that in a form which is unmanifest, and that I will call as information. Otherwise, it cannot appear. That's what I'm trying to say.
Yes, I kind of get what you mean. So you can draw parallels because there are many theories and there are many understandings where you can create a particle and something called as an antiparticle from this vacuum. So it seems to be as though you're creating something out of nothing.
Right.
Yes. So you can draw a parallel here, but I wouldn't say it's exactly the same thing.
Yeah, something to come out of nothing. Okay, the bridge is the knowledge or information which is available to appear. It may not be a matter, it may not be a particle, it may not be a wave, but information which is very different from particle or wave.
Yeah, but I don't think you can draw a 1:1 parallel here, because all that science is doing is you are always working in the realm of something. So what we define as a quantum vacuum is still something. So now if you say something appears from nothing, there is no, so science always looks for, so then if you say something appears from nothing, science always looks for nothing as well, because you need to draw correlation between something and nothing.
Which is not possible, no?
Which is not possible. So science always works in the realm of something.
Okay, science always works in the realm of something. So
yeah,
I would look at the realm of nothing. I'll say nothing has information about something.
Well, infinity always has information about infinity. So,
okay.
So again, like, so if in the field of science you want to define these things, then you will have to define what nothing is, which by definition is contradictory. So science always works in the realm of something. So the way it becomes close to Vedanta is in these kind of aspects, where the idea is present. The idea of something coming from nothing is present, because in theories that we have right now, you can pull out particles from something called as a quantum vacuum where there is no particles. And it seems to violate all our ideas of preserving of something out of nothing. You can't get something out of nothing, kind of a thing. So it still preserves some aspects, like it still conserves something called as energy. It still our definitions of energy. It still conserves something called as momentum and things like that. There's physics to it. But the idea of something of or a particle coming from nothing is there in that theory, and and it is these kind of ideas that actually draw people to these kind of philosophies of Vedanta that we have, because they seem to permeate the same concepts.
Yeah.
And that's why I say quantum physicists are the best people to turn towards Vedanta.
That's true.
And quantum different models, and string theory also has relation to Vedanta.
So it's all part of the same model. So quantum field theory is one of the, the way we understand the universe is we have four fundamental forces. Now we have been able to combine three of them and find a point in time of the universe where all these three were combined into one. Now we want to find a theory where all these four were combined into one, the most primal form of physics that was there in the universe, and that we haven't been able to do it in some traditional ways. And string theory is one of the ways where people have tried to bring all of the four together.
Okay.
And but the sad part about string theory is there is no way to go physically experiment because it says there are things that your particles and everything lives in 10 dimensions of space, and we only deal with 3. We only have 3. That is a problem. So the problem is string theory is now like scientists are hopeless to experiment. So all of string theory is just some thought experiments.
Yeah. Excellent, Pranav. And so if there are any more questions from anyone, let's give a minute for that. Otherwise, we are already 8:10, so we want to close that. Vinay and Preeta, do you have any questions?
Preeta will have questions at home.
Okay.
Okay, we close for the day.
Thanks, Pranav.
Thank you.
Thanks everyone for joining. Let's close this.